This is a React app referencing an environment variable, and this is the JavaScript file your users actually download. That's your API key, in plain text, shipped to every browser. Or maybe you've hit this one. Your app runs fine locally, but the moment it's in Docker or CI, it can't find a variable that's right there in your .env file. We treat environment variables as copy-paste configuration and don't usually think about what's happening underneath. In this video, we'll see what environment variables actually are at the OS level, work through how they move between processes, which explains most works on my machine problems, and end with the build time versus runtime split. Before environment variables were a web dev concept, they were an OS concept. Every process running on your computer, your browser, your terminal, your node server, has its own block of memory called its environment. It's just a flat list of key-value pairs, strings mapped to strings. No nesting, no types, just text. Open a terminal and type printenv. You're looking at your shell's environment. There are usually dozens of them, and most were set by the OS long before your code entered the picture. Like path. When you type node, your shell splits this variable at the colons and searches each directory until it finds a match. That's not a node feature, that's your operating system. Environment variables are an OS primitive. Everything else is built on top of that. So where do all these values get set? They come from multiple layers, and the layers stack. Layer 1, the OS sets baseline variables like home and user when your machine boots. Layer 2, your shell profile, files like .zshrc that run when you open a terminal. This is where we add to our path. Layer 3, manual commands, export for the whole session or the inline prefix syntax for a single command. Layer 4 is application tooling. This is where .env files come in. And a .env file is just a text file. It does nothing on its own. Something has to read it. In Node, that's traditionally .env, though Node now has a built-in --end file flag. Python has python-env. Docker Compose has its own loading. Each tool has its own rules. Most of these tools, including .env, will not overwrite a variable that already exists. If your shell profile exports database URL and your .env also sets it, your shell profile wins. The .env file fills in gaps. It doesn't overwrite. So this can be one of the most common debugging rabbit holes. You're staring at your .env, the value's right there, but your app reads something different. An old export in your shell profile is silently taking priority, so don't forget to look there. And another thing while we're talking about .env files, these often contain secrets, API keys, database credentials, so they should always be in your .git ignore. And if you've ever accidentally committed a secret and then deleted it in the next commit, that doesn't fix it. Git keeps every snapshot. The key is still in your history. Anyone who clones the repo can find it with a git show. So the rule is simple. Secrets go in environment variables, never in source code. If it's sensitive, it doesn't get committed. Okay, so we know what environment variables are, where they come from, and what goes in them, but how do they actually get from your shell into your application? That's what process inheritance explains. Quick question. If you set a variable in your terminal and then launch your app, can your app see it? Yes. If your app changes that variable, can your terminal see the change? No, and here's why. When a process creates a child process, the child gets a copy of the parent's environment, not a reference, a copy. They're independent from that point on. Let's actually see this. I'll set a variable in my shell, read it from Node, works fine. Now I'll change it inside Node, confirmed it changed there. Back in the shell, still hello. The child's change didn't propagate back up. Independent copies. This is exactly what happens with Docker. Your shell has dozens of variables loaded from your profile, but when you run a Docker container, it starts with a clean slate. It doesn't inherit your shell environment. You have to explicitly pass in everything it needs with -e flags or --n file. And this is why your app works fine on your machine but breaks in Docker. The container only knows what you explicitly told it. Same thing in CI. Each run step in GitHub Actions gets a fresh shell. Variables you export in one step don't carry to the next. You need GitHub_env for that. Different CI systems, different mechanisms. Same underlying reason. Environments are copies that diverge. Knowing that can save you some headache. And that React example from the beginning of the video, why the API key ended up in plain text in the browser? Let's look at build time versus runtime. Build time configuration, values read when your code is compiled or bundled. They get embedded in the output. Once the build is done, they're frozen. Runtime configuration, values read when your app actually starts running. You can change them between deployments without rebuilding. Sounds like a clear distinction, but it gets confusing. In a React app, or any front-end app, when you write process.env.reactapp_API URL, it looks like you're reading an environment variable. You're not. Watch what actually happens. I'll build a React app, then search the output files for my variable name. And there it is. The bundler replaced every reference with a literal string. It's hard-coded into the JavaScript, which means anyone can see it. Open DevTools in your browser. Click Sources. There's your value, in plain text, shipped to every user. If you put a secret in a React app or next public variable, it's not secret. It's in the bundle. And there's another consequence. If you build your front end with a staging API URL, you cannot take that same build and deploy it to production. The URL is baked in. You have to rebuild. That means the artifact you tested in staging is not the artifact running in production. You rebuilt, so it's technically a different artifact. Frameworks try to make this clear. Next.js uses nextPublic for build time client variables. Server-side code reads real environment variables at runtime. Vite uses Vite with import.meta.env. Each framework has its own prefix, but the rule is the same. Prefixed variables go to the browser. Everything else stays on the server. Compare that to a backend. When Express reads process.env.database URL, it reads the actual environment of the running process. Change the variable, restart, new value. No rebuild needed. That's true runtime configuration. Rule of thumb, if a value can't change after the build, a public API URL per deploy pipeline, a feature flag for tree shaking, build time is fine. Everything else should be runtime. Secrets should always be runtime. Never build time, never committed to code. Same idea in Docker. ARG is build time. It only exists during the image build. env is runtime, baked into the image and available to containers. You can copy an ARG to an env, but then the value is in the image layer. And both ARG and env values end up visible in Docker history. ARG values aren't available inside running containers, but they're recorded in the image metadata, so neither of them is safe for secrets. Pass secrets at runtime with docker run-e or your orchestrator's secret management. For secrets, think of it as a spectrum. At the bare minimum, use .env files in your .gitignore. Better, a secret manager like Vault or AWS Secrets Manager that encrypts at rest, logs access, and can rotate credentials automatically. Best, have your infrastructure inject short-lived credentials at runtime. Your app never stores a static key. Build time, frozen into your artifact. Runtime, flexible until the moment it's read. Secrets, always runtime. Never build time, never committed to code. To bring it all together, environment variables are an operating system primitive, flat strings on every process, not a framework feature. They come from layers, OS, shell, commands, tooling, and those layers have a precedence order. Child processes get a copy of the parent's environment. After that, they're independent. That's why Docker and CI behave differently from your local terminal. And build time configuration is not the same as runtime configuration. One is frozen in your artifact, the other stays flexible. Secrets should always be runtime, never build time, never committed to code. None of this is advanced, it's foundational. If this was useful, like and share. Thanks for watching, and see you in the next one.